Hello students, welcome to Alphos e-learning session 61. Penacol rearrangement of alcohols we are going to discuss. In previous session we was learned few examples of penacol rearrangement in which ring expansion, ring contraction, in which compounds preferably takes place. Similarly, by using which isomer you are getting which product. In some cases, whether it is cis or trans, you are getting same product. And similarly, in some cases we are expecting different product, but we are getting ring contraction product. And in few compounds looks like they also follows penacol rearrangement, but which compounds generally do not follow penacol rearrangement, that contents we already learned. In this session, we are going to discuss in cyclic vicinal diols how penacol rearrangement takes place. Let us see. This is vicinal diol, 5-member ring consisting vicinal diol. This vicinal diol upon acidification, one of the OH group gets protonate, then we are getting product OH2 plus, and here OH remains there. And further, this OH2 plus will leave away as water molecule. Here this group comes out. Now we are getting product here positive charge. Formation of carbocation. Which carbocation we are getting here? Tertiary carbocation. And later here ring expansion. That means here what happened? This 5-member ring as such. Now, because of the bond in between these two carbon atoms is going to break, and in between these two carbon atoms, bond formation takes place. Because of these electrons goes to this carbocation, here this carbon loses positive charge, and now this carbon lost electrons. That's why this carbon is going to get positive charge. That means here in between these two carbon atoms, bond formation, and there will be a 6-member ring here. And with respect to this carbon, next carbon consists OH, and this carbon consists OH. Now this carbon is going to same OH group containing carbon only base positive charge. Later you know very well here these electrons will be given to positive charge. Then we are getting double bond OH2 plus, and next step this H plus comes out. Then we are getting product here double bond O. This is product. So here ring expansion takes place. Now simply give you this compound acidification first, means because of acidification we are getting product this one. If this one upon treatment with sodium borohydride, means here penacol rearrangement completed. But here what happened further upon reaction with NaBH4, sodium borohydride. Sodium borohydride is a mild reducing agent. It can reduce carbonyl compounds into. So upon reduction with sodium borohydride, here C double bond O group get reduced, means it reduces because of mild reducing agent. It can reduce carbonyl compounds into alcohols, aldehydes into primary alcohols, ketones into secondary alcohols. But sodium borohydride cannot reduce carboxylic acid and its derivatives except acid chloride. And now here we are getting C double bond O group is going to convert into OH group product. Suppose this one further acidification. Next what happens here? this OH group gets protonated and it turns to carbocation, means OH converts into OH2 plus and it leave away and formation of carbocation. Next step, we have this ring expansion takes place. This 5-membered ring is going to convert into 6-membered ring. Then we will get a product here. We will get product here like this. Now in final step, this H plus comes out, deprotonation, and we are getting product like this. So this is ultimate product. Penacol rearrangement followed by reduction with sodium borohydride followed by acidification. So final product we are getting this product. Now let us try here if both are 4-membered rings. Both are 4-membered rings. In such a case, what happened and how reaction mechanism proceeds. Students, have a look here. 4-membered ring containing vicinal diols, which upon acidification, first penacol rearrangement followed by sodium borohydride, we are getting ketone, that ketone reduced to alcohol, which upon further acidification, we are getting again rearrangement. What product we are getting? And in second example, one is 5-membered ring, another one is 6-membered ring. Here also both OH groups are attached to adjacent carbons, means vicinal diols only. This one upon acidification means protonation. As it is very clear, one of the OH group gets protonated and either of the 2 carbon atom bears positive charge. And after formation of positive charge, how reaction takes place? You know that? Here after formation of positive charge, 6-membered ring contracts to 5-membered ring. 6-membered ring contracts to 5-membered ring. And check out that product how you are getting. And in this case, it is also simply vicinal diol. Here both OH groups and 2 methyl groups, means both are in the same environment. No more confusion. One of the OH group gets protonated and it leaves as water molecule. After that formation of carbocation, and after formation of carbocation, here ring expansion and ring contraction both are not possible. Here still methyl groups are there. That methyl migration takes place. Because of methyl migration takes place, we are getting ketone. So try to write mechanism for these 3 examples. Students, so far we learned penacol rearrangement for various compounds. So how mechanism takes place and what are the possible products we are going to get, we learned. Now similar to that, one more mechanism, this is what we call the semi-penacol rearrangement, also called Tiffin-out division or rearrangement. So in this semi-penacol rearrangement, how mechanism proceeds and what type of reactants are going to take part in the reaction, let us see. In case of a penacol rearrangement, we learn clearly vicinal diols are going to take part. So because of vicinal diols, here adjacent carbon atoms are going to get consist OH group. But in semi-penacol rearrangement, one carbon is going to bear OH group and another carbon consists what group, and which we can convert into good leaving group. I am repeating, in semi-penacol rearrangement, one of the carbon is going to bear OH group and its adjacent carbon consists a group which we can make it into good leaving group. For example, here I used to consider NH2 group. So as we know that NH2 group, if you want to convert into leaving group, that means we need to convert that into N2 plus. Means NH2 group converts into N2 plus by diazotization. So here diazotization, for diazotization HNO2 we have to use, and we know very well nitrous acid is highly unstable. That's why we are going to use NaNO2 and HCl. So when we are using NaNO2 and HCl, instantaneously inside of the reaction HNO2 can be prepared. Now I am going to explain mechanism here. RNH2 upon reaction with HNO2 HNO2 double bond ON OH. Here condensation takes place. RN double bond NOH. This one upon further acidification, we are getting R double bond N OH2 plus, and this one when we are using HCl, NaNO2 and HCl, and whenever it leaves, this nitrogen gives electron pair, and we are getting RN triple bond N plus and Cl minus. This is what we call diazonium salt. And as NH2 converts into N2 plus, now this one we can say it is a good leaving group. It is a good leaving group. Now, whenever upon reaction with HNO2 instead of HNO2 NaNO2 and HCl, then reaction proceeds here. OH group as such and pH. Here carbon consists N2 plus and CH3. Here CH3. Now, as we know very well, N2 plus is good leaving group and this one leave away. Now, what reaction proceeds here? Formation of carbocation. Once formation of carbocation means almost we completed half journey of Penacol rearrangement. So in Penacol rearrangement also formation of carbocation, and after formation of carbocation, what will happen? Same there and here in both cases. Now migration of phenyl group here, migration of phenyl group here, then we are getting PHCOH, here positive charge. This carbon is going to bear one phenyl group and methyl group, and later this oxygen is going to donate electron pair, and we are getting product PH, C double bond O, CPH, CH3 and CH3 by losing proton. So here also we are getting ketone. But reactant or substrate is not vicinal dipole. One carbon consists OH group. Its adjacent carbon consists a group which we can convert into good leaving group. Like here, we used to consider NH2 group. Students, if no division or rearrangement, let us see this example. Aminohedrin, we know chlorohedrin, OH and Cl if attached across double bond. The NH2 and OH if across double bond, that what we call aminohedrin. Here this is aminohedrin. And in previous session we learned that how Penacol rearrangement takes place. 1, 2 dimethyl cyclohexane, 1, 2 diol. In such a case, whether you consider cis or trans, actually only two possibilities are there, cis and trans. Whatever the substrate, whether it is cis isomer or trans isomer, you are getting ring contraction product, means 5-membered ring ketone as major product and 6-membered ring ketone less than 10% product will learn. Now I am going to consider the same compound, but instead of two OH groups, one is OH, another one is NH2. Now, in such a case, how this semi-Penacol rearrangement or Tefino-Di rearrangement takes place, let us see. If you observe here, this one not only exhibits geometrical isomerism, but also exhibits optical isomerism. Here, both the carbons are chiral carbons, that's why so many isomers are possible. Here I used to consider 4 isomers. Let us see that 4 isomers. Basically, these are belongs to two categories, cis and trans. But there are 2 trans forms and 2 cis forms. Here 2 trans forms exist and 2 cis forms exist. So here this one is trans and these 2 are trans and this one is cis. One more cis also I am going to show here. Now this one upon reaction with the HNO2, as we know that diazotization. Because of diazotization here, NH2 group converts into N2 plus. Fine, here NH2 converts into N2 plus. And this methyl group is here, and this methyl group is here, and OH. Now, by leaving this N2, there will be formation of carbocation here, and CH3 like this, CH3 like this, here positive charge. And this OH is here. If you observe, both methyl groups are axial, means equatorial here, and NH2 and OH, these two are axial. In other words, we can say this NH2 group and this OH group, these two are anti, means anti-periplanar. Because of anti-periplanar, here the ability to donate its electron pair will be more. I am repeating. Here the ability to donate its electron pair will be more. Means in general what we are expect, after formation of carbocation, methyl migration has to take place. But here methyl migration do not take place. Instead of that, this oxygen is going to give electron pair. Oxygen is going to give electron pair. Result and the product formed here two methyl groups like this and like this OH plus, and from this, by losing this proton, we are going to get product. Here it is epoxide and these two are methyl groups. That means here penacol, semi-penacol rearrangement or semi-penacol rearrangement do not take place. Observe here. First step, diazonization, NH2 converts into N2 plus, and the N2 plus is good leaving group, and its leaving ability promoted by this OH group. Earlier we was learned that anchimeric assistance or neighboring group participation concept. Here the same concept. Here N2 plus, it makes this oxygen makes that N2 plus to leave away much faster by donating its electron pair to N2 plus containing carbon. Resultant we are getting epoxide. There is no more rearrangement. So one of the trans compound do not gives any rearrangement product. Let us see what happened in another trans compound. So first of all, HNO2. Upon reaction with HNO2, here what happened? NH2 group converts into N2 plus. NH2 group converts into N2 plus, and this N2 plus is now good leaving group. It has tendency to leave away as N2. Resultant, we are getting product here carbocation. And if you observe here, with respect to leaving group, here in this case, with respect to leaving group, OH is these two are axial. Because of both are axial, we can say this OH group promotes that leaving tendency of N2. Whereas in second case, if you observe, leaving tendency is not influenced by methyl group, means OH group. Of course, methyl group cannot do anything. Here, after formation of carbocation, there are two possibilities. One is either methyl group has to migrate or methylene group has to migrate. As methyl group has to migrate or methylene group has to migrate. So this case already we discussed. Here methyl migration is quite difficult. Hence, here what happened? CC bond, sigma bond electron pair will be shifted. Resultant 1, 2, 3, 4, 5. There will be formation of 5-membered ring. 5-membered ring. One position occupied by methyl group here. So where methyl group is there C carbon consists OH and CH3. Here this carbon consists OH and CH3. Now the same carbon is going to bear positive charge. Further what happens here? Here oxygen going to donate electron pair and it forms C double bond OH plus. Further deprotonation takes place. Because of deprotonation here we are getting ketone. See students, I used to consider same isomer. In first case also trans isomer. In second case also trans isomer. But both are having same configuration like trans, but the stereochemistry is not same. The stereochemistry is different. In first example, NH2 and OH both occupies axial and axial. Means leaving group is departing from axial position and supporting or promoting group also promotes from axial position. Now, I used to consider one more trans conformation here, and in this case, both these axial positions occupied by two methyl groups. Both the axial positions occupied by two methyl groups. Because of both are methyl groups here, departing one is NH2 which occupies equatorial position. Now this equatorial NH2 is going to convert into N2 plus. And after leaving this N2 we are getting carbocation, and towards the carbocation what happened here? Methyl migration or methylene migration. So methyl migration is quite difficult. So compared to that, methylene migration takes place. That means Cc sigma bond electrons are going to transfer towards carbocation. Resultant this Cc bond breaking takes place. Now here carbocation formation takes place, and towards this carbocation, this carbon containing oxygen is going to donate electron pair. Resultant carbon oxygen double bond formation takes place. Now by ring contraction we are getting ketone. Same amino head ring. Just now we discussed two transforms, of which one gives semi-penacol rearrangement and one forms simply epoxide. Because of, with respect to leaving group, the one which is anti-periplanar, if that group is electron rich, it promotes the leaving tendency. Now let us see here in these two cis conformations, whether penacol rearrangement type means semi-penacol rearrangement proceeds or not. Let us see. Here this one upon reaction with HNO2 nitrous acid, then NH2 group is going to convert into N2 plus, and this NH2 diazotization and converts into N2 plus. Remaining groups as such. So if you observe here, two methyl groups are, one is equatorial, another one is axial. Here also two methyl groups are, one is equatorial, another one is axial. But difference arises here with respect to NH2. If you observe, here NH2 is in the axial position, and towards this axial position, here axial position methyl group is there, and here NH2 is equatorial position. And this equatorial position, with respect to this equatorial position here, methyl group is in equatorial, looks like same, but let us see the mechanism, how it proceeds. Here methyl and OH, here methyl group. Now this N2 will leave away. After departing that N2, whenever this N2 leave away, here what happened? Methyl migration proceeds, methyl migration takes place. Because of methyl migration means methyl group migrates here, resultant we are getting two methyl groups here, and here OH, here it bears positive charge. Now this oxygen is going to donate electron pair, resultant we are getting product here CH3 and double bond OH plus. This one upon deprotonation we are getting product cyclohexanone 2,2 dimethyl cyclohexanone. This is the product. Whereas let us see in case of second cis isomer, but here NH2 group is in equatorial position. Whenever NH2 group is in equatorial position, obviously that NH2 converts into N2 plus, and methyl group here OH group, here methyl group. And after departing this N2 plus here, with respect to N2 methyl group is there, whenever N2 leaves here what happened? This Cc bond is going to shift, means methylene shift takes place. Resultant again we are getting 5-membered ring. And 5-membered ring consists CH3 and here COH and CH3 plus. Now this oxygen donates electron pair, resultant we are getting the same product as what we got in earlier case, C-double-bond-O CH3. So there were two trans and two cis, and of the two trans, both the trans isomers do not give same product, and both the cis isomers do not give same product. So one cis isomer and one trans isomer, both products are going to match, means they are giving same products, and one trans isomer forms epoxide and this one forms here cyclohexanone, 1,2,2-dimethyl cyclohexanone. Now let us see remaining examples. What reactants or what substrates can participate in semi-penacol rearrangement? Now, I used to consider halohedrine. Suppose pH, C, OH, pH, C, Cl, CH3 and CH3. Here, HOCl addition across carbon-carbon double bond, we are getting halohedrine. So in such a case, how mechanism proceeds, have a look. This one upon reaction with AgNO3, as we know that AgNO3, Ag plus, and this extract that Cl minus and AgCl precipitate out, means ultimately we are getting formation of carbocation. Here CH3 and CH3. After formation of carbocation, what happened? Migration of phenyl group, and we are getting product pH, C, OH, C, CH3. Because of this phenyl migration to this carbon, here this carbon gets phenyl group, and now this carbon is going to bear positive charge. Now here oxygen is going to donate electron pairs, and we are getting pH, C double bond O, C, pH, CH3 and CH3. See here, we are expecting more stable carbocation here because of two phenyl groups are there. But unexpectedly here, chlorine is not attached to that carbon, particularly the carbon which attached to two phenyl groups. So, where the carbon which consists Cl or any halogen like Br, in such a case, there only means that particular carbon only going to bear positive charge. Even though here OH group is there, it does not form any positive charge because this reaction is not going to proceed in acid medium. Okay, fine. Sir, if the same substrate I am going to provide acid H+, then what happened? So what happened here? OH group get protonated. In such a case, chlorine shows antichemical resistance and it forms 3-membered ring, haronium. Later further reaction OH minus again attacks any of the carbon atom. Now, instead of Cl, if we are going to consider Br, can we expect the similar reaction? Instead of Cl, if you are considering Br, yes, obviously the same product with AgNO3. Here Ag plus combined with Cl minus, nothing but Ag plus locked that Cl minus by forming AgCl as uniodized. In other words, precipitate formation takes place. Similarly, in case of Br also, compared to Cl, Br much more readily gives this product because of AgBr solubility is much more less compared to AgCl. Now, here, if I am going to perform penacol rearrangement by using two substrates, I am not discussing regarding Dimzano rearrangement. I am not going to discuss regarding Dimzano rearrangement. I am asking penacol rearrangement by using two substrates. Have a look here. All the two substrates are there. pH, C, pH, OH, and this carbon methyl and OH plus pH, C to H5, OH and OH. Individually, if these two substrates are involving in reaction, then what products we are going to get? We know that. Like here, out of these two OH groups, this OH group is going to protonate, and here carbocation formation takes place, methyl migration takes place. Now, what product we are getting here? In presence of acid, pH, carbon, pH, because of methyl migration CH3. Here C double bond O CH3. This will be the product. Now, if this compound only involves in reaction, then in such a case, again this OH group gets formed, OH2 class will leave, then ethyl migration takes place. In such a case, pH, C2H5, C double bond O, CH3. Now, these two are the products if these two are the reactants individually upon acidification. But now my question is, when these two are, we are going to consider the same reaction, means both are substrates. Both are substrates. What products we are going to get? I am repeating once again. If both the reactants are there in the same reaction, now straight away I am asking, is there any possibility this methyl group has to come to this carbon and this ethyl group may goes to this carbon? Such products are possible or not? If possible, how many are there? If not possible, why? That reaction, try to write the complete mechanism.